A store has reduced the price of an item. We don't know what the item is. From $35 to $14. What is the percent of decrease? All right, let me read that again. A store has reduced the price of an item from $35 to $14. What is the percent of decrease? All right, so we're talking a percent problem here. We're dealing with percent. So remember, when we deal with percent, we've got to figure out where do we start, where are we going, and what numbers are we going to need? Now, this one's got a little bit of distractor, so let's take a look at this problem. Let's take a look at it, all right? It says a store has reduced the price of an item from $35 to $14. So first of all, it says, that's telling me something. It says we've knocked how much money off this thing? We've knocked $21, my friends. You've gone from 35 to 14, so that means we're taking away $21. That's a good price. It's a good decrease. That's a great sale price. That's more than half, all right? So it says, what is the percent of decrease? So what we've got to do, first of all, is figure out how much did this decrease and where did it start, all right? So let's look at this deal. We think of the formula as being, and I'm going to go proportional on you today, okay? As from part over the total, or sometimes we call that the base, and that would equal to that percent over 100. There's our formula. So what we want to do, we want to figure out what is it we're looking for. This, folks, is what we're looking for. We're looking for the percent. Notice it says, what is the percent of the decrease? Percent always goes over 100. So what we've got to do is figure out what numbers are going to play the role of the part and our base. Where did we start from? So let's go back and look at the problem. The beginning is starting at 35, and then we end up at 14. So what does the 14 do? It tells me the part, it's not 14, it's how much decrease did we have, all right? So we made it to 14, that's where we ended up. The decrease, the part here, is 21, all right? So that's the first thing. The base, where did we start at? Was 35. So there we go. We are on our way. We are on our way. Is everybody with me? Everybody got it out there? Now, on the other side, I don't know what the percent is. I'll call it X. You can call it N, call it whatever you want. And it's going to be over 100, because that's what percent simply means. Take a number and divide it by 100, all right? And that's how you get a percent. You may look at it as a decimal. You can look at it as a whole number or an integer or even a mixed number kind of thing over 100. But the idea is that's what's going on here. So let's do it. What are we going to do? Let's cross multiply. That's the next game plan here. So we're going to multiply 35 times x, and we're going to take 21 times 100. So what this is going to give us is 35x equaling to value of 2100 here. Now I'm going to take it off to the calculator on this so we can make sure. I think this is going to come out pretty nice and even, but let's take and divide 2100. And we're going to divide it by 35. Make sure you get the right keys. And don't put too many zeros in there. We don't get carried away. And it looks like we got 60% on this. So that's where we are. When we divide by 35 to both sides here, we're going to end up with x equals 60. And friends, that is a percent this time. That's not the part, that's not the total, not the base, that's the percentage, all right? And there you go. There is your problem of the day. Another way we could look at this, another way we could look at it real quickly, we could take 21 over 35 and ask ourselves, what is that going to equal as a decimal, all right? So let me hit that real quick here, and we'll see, hopefully, a good thing. How about it? 21 divided by 35. And it comes out to 6/10. You say, well, Ernie, that's not the same thing as 60. But it is, because what happens when we get 6/10? That's another way we can write a percent as a decimal. So we want to get it back to the actual percent. Don't say 6/10 of a percent. No, no, no. We're going to move this thing 2 places, and guess what we have? We have 60%. So either way you look at it, some say, well, can we go this route? Sure. If you want to use this proportional approach, that's also another great way to do it. You get to the same value, and you'll get this, and you basically the same gist of the problem, okay?
For more math help, visit TNLearn.org.